this video, we shall be solving a question concerning graphs of polynomials, and we'll be getting a question from one of the past papers. So this question says, the diagram below shows the graph of y is equal to x to the power 3 plus x to the power 2 minus 5x plus 3. Y is equal to x to the power 3 plus x to the power 2 minus 5x plus 3. So now the question is saying use the graph to, number 1, calculate an estimate of the gradient at the point 2, 5. So calculating the gradient at the point 2, 5. Now, the first step that you have to do is go where there is 2, 5. Now, 2 is on the x-axis, so it's this point. I'm sure I can see the point right there. That's the 2. Then the 5 is somewhere up here. So this is 10. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5 is in the middle here. 1, 2, 3, 4, 5. So this is 5. So now we are calculating our gradient from this point. So when we want to find the other points that we use when calculating the gradient, since when we want to calculate the gradient, we use the formula gradient is equal to y2 minus y1 over x2 minus x1. Now in this equation, we would need 2x and 2y's. So now here we only have 1x and 1y, of which have been given as 2, 5. So we need to extract 2 more points to make our equation complete. So before we even do that, you first have to write a tangent at the points they've given you. Now a tangent is just a line touching the surface of a circle or a curve, like this one right here. So it doesn't have to pass inside the curve, but only touches the curve. So you draw a tangent, a straight line touching the curve. Like that. So you use a ruler. Then now you pick any point on this line that you've drawn. Yeah, you pick any point that will be useful when you want to calculate the gradient. So if I pick this point, for instance, this point is 3, this is 10, 11, 12, 13, 14, 15, 16. So this is 3, 16. So we have our 2 points as 3, 16, and we also have another point which is 2, 5, which were initially given. So this we can name it as x1, this can be named as y1, this can be x2, and this can be y2. Now proceed to using the formula. So gradient is equal to our y2 here is 5 minus our y1, which is 16, over our x2, which is 2, minus x1, which is 3. From there, we'll get a negative 11 over a negative 1. So when you have two negatives like that, they'll give you a positive. Then to be 11 over 1, which will be 11. So you say, therefore, gradient at 2, 5 is equal to 11. There, you are done with the first part of the question. The second part of the question is saying, solve the following equations using your graph. So we have our first equation, which is x to the power 3. It's x to the power 3 plus x to the power 2 plus, minus 5x plus 3. Then our b is saying x to the power 3 plus x to the power 2 minus 5x plus 3 is equal to 5x. So if we look at our first equation, we can clearly see that this equation is the same as the original equation for the curve. So what you have to do, you first have to cancel out the things that are similar on both equations. So as you can see, we have x to the power 3 on both equations. So you cancel the x to the power 3. Then you also cancel the x to the power 2. You also cancel the negative 5, the 3, and you have nothing. So we can just conclude to say you have 0. So you say y is equal to 0. So now if you find your y is equal to 0, you just go where on your graph, then you go where the curve cuts the x-axis. So as we can see, this graph cuts the x-axis at this point. So you have the first point, which is this point. Yeah, we also have this point. So only have 2 points in this case. So the first point is negative 3. So you can conclude to say your x is equal to negative 3. Then also at this point is positive 1. So x is equal to 1. So from there you've solved your graph. Yeah, you've solved your equation using the graph. So all these have to be shown on a graph. Then we have the second equation, and as can be seen, these are also similar to the first equation. So you cancel out the x to the power 3 is the same as the x to the power 3 for the original equation. X to the power 2 is also the same as for the original equation. The negative 5x and the 3. So you can say y is equal to 5x in this case. So for this one, this is a line, a straight line. So first of all, when you're solving this type of equations, you first have to make a table of values. So you can pick any two values for x, any values that you would want. So we have x and y. So I've picked 0 and 1. So you say y is equal to 5, or you put the 0, then you get your y as 0 at this point. Then when you put a 1, you get a 5 times 1. Your y will be therefore a 5. Now, you have these points. So what you simply have to do, you just have to plot these points on your graph. So I have 0, 0, which is the origin. And then we also have 1, 5. So our 1 is right here, and then our 5 is right here. So meaning your line has to pass at this point. So you can name this as y is equal to 5x. So this is the line for y is equal to 5x. Now, remember that you're not done with solving the equation. Now, you go back to the equation, so you can even extend this up to even the bottom. So now you go to your curve, and then you check where this line is cutting the curve. So as we can see, we have this point. We also have this point. And we also have this point. So those must be your answers. So remember, this is x and this is y. You only pick the coordinates for x. So it has cut this curve at negative 4. So you say your x is equal to negative 4. Your x is also equal to this point where this line has cut the curve. This is 0.5. So x is equal to 0.5. Then lastly, your x will be at this point, which is 2.5. So x is equal to 2.5. So these are your 3 answers, and I'm sure this question has got 3 marks. Yeah, so you have done with the second part of the question. Then lastly, it says find the equation of the tangent to the curve at the point where x is equal to 2. So this type of question is calculus. Yeah. So when you are dealing with this type of question, which says find the equation of the tangent to the curve y is equal to x to the power 3 plus x to the power 2 minus 5x plus 3 at the point where x is equal to 2. So for this one, you first have to find the value of y, I guess here. So your y, so where there is 2 is this point, then it lines with the curve at that point, which is 5. So your y in this case is 5. First of all, you have to derive this equation. Now, why am I derivating this equation? So I'm derivating this equation to get the gradient function so that I can find the gradient, which I will later use to find my equation. So you say y is equal to, remember when we're derivating, we subtract the power by 1 and multiply the same power by the number that is before the letter. So say 3 times 1, which will give us 3, x to the power 3 minus 1, plus 2x, 2 minus 1, minus 5x, 1 minus 1. Then the one that doesn't have any letter, just cancel it out. From there you say y is equal to 3x to the power 2 plus 2x minus, this will be x to the power 0. Any number to the power 0 is 1. So here we'll have 1 times 5, which will give us a 5. So this is our gradient function. So you proceed to say y is equal to, where there is x, you put the x they've given you, which is the 2 squared plus 2 times 2 minus 5. From there you say 3 times 4 plus 4 minus 5. Then you get a 12 there plus 4 minus 5. Then you get a 16 minus 5. Then you get 11. So that's your gradient. So you can say gradient is equal to 11. So now you use the equation of a straight line to find this equation, because this is a straight line. So you say y is equal to mx plus c, where c is the y-intercept. So you say your y is 5, your gradient is 11, your x is 2 plus c. Then you say 5 is equal to 22 plus c. Then you say c is equal to 5 minus 22. So c will be equal to 17. So that's your y-intercept. So then you get the equation again. Then you say y is equal to, you put your gradient 11x plus 17. From there you found your equation. So you can just say, therefore, the equation of the tangent at x is equal to 2 is y is equal to 11x plus 17. And then you are done with the full question. Here you are rest assured of getting the 6 marks. That's all, and see you in the next video.